Alrighty, let's go ahead and work these out. So the first one is find the exact value of cosine of 75. So when the special degrees that we know are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And so you have to figure out how can these be combined to get 75. All right, so let's see if we can figure this out. So we have, I'm winging it here, 45 and the 30. Sorry, it's already past 2 in the morning. So notice that these two would add up to 75. So this is the same as cosine of 30 degrees plus 45 degrees. Okay, now remember the little jingle? Sine, cosine, cosine, sine, cosine, cosine, sine, sine. So this is going to be cosine, cosine. So cosine 30, cosine 45. And then for cosine, the signs flip. So this is minus sine 30 and sine of 45 degrees. Okay, now doing what we know, and I had the table up here because, memorizing this is a thing that is never fun, and I always forget it all the time. But when I'm taking a test or when I'm just need to remember and refresh myself, I always have this table to help me out. And I pasted it somewhere. Here we go. Doop 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 doop. It's moving, moving. There we go. Okay, and so all you got to do is once you create your table, just adjust the angles. So this is 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. All right, so let's go ahead and do this. So cosine of 30 degrees is square root of 3 over 2. Okay, cosine of 45 is square root of 2 over 2. Minus sine of 30 degrees is 1/2. And then sine of 45 degrees, 45 degrees is square root of 2 over 2. Okay, top times top. This is square root of 6 over 4 minus, and then square root of 2 over 4. And notice that the answer is just square root of 6 minus square root of 2 over 4. Yay! So hopefully you got that when you work it out. So now the next problem is pretty much the same thing, except it's with sine. And why is that S not erasing? That's erasing. Okay, I don't know why it's not erasing. Anyway, we're just going to have to deal with it. So find the exact value of 7 pi over 12. So the numbers that make up 12 are 3 times 4. So it's probably going to be with the third and the fourth. So 0, pi over 6. Could also be 6 and 2. Pi over, my brain's not working. Pi over 4. Pi over, it's been a long night. I just spent a couple hours cleaning my kitchen because it's tomorrow's trash day. All right. Ugh. Okay. So we got 0, pi over 6, pi over 4, pi over 3, pi over 2. And so how can these numbers combine to give us 7 pi over 12? Okay. So 7 pi over 12 is more than pi over 2. So I'm going to have to be adding things together. And so I can try it out. I can try pi over 6 plus pi over 2. That's 2 pi plus 6 pi over 12. That's 8 pi over 12, so that's not it. So we can try a pi over 4 plus pi over 3. Okay, and that's going to give me 3 pi plus 4 pi over 12, and there you go. That's your 7 pi over 12. So this is going to be sine of pi over 4 plus pi over 3. And so now this is sine. So sine is sine, cosine, cosine, sine. So sine of pi over 4, cosine of pi over 3. Now for sine, the sign in the middle stays the same. And then cosine of pi over 4. And then sine of pi over 3. I don't know why that s won't erase. So I'm going to kind of work around it. So sine of pi over 4 is square root of 2 over 2. Okay. Cosine of pi over 3 is 1/2. Then we have plus cosine of pi over 4 is square root of 2 over 2. And then sine of pi over 3, that's the same as sine of 60. That's square root of 3 over 2. So we have square root of 2 over 4 plus square root of 6 over 4. And notice that gives us, so we're getting answers that look very similar. All that changes is the order in which they're done. So square root of 2 plus square root of 6 over 4. Alrighty. So hopefully you got those. Now let's go on to proofs. So the next two are proving, or the next one is proving that sine of 90 minus a equals cosine of a. Okay, so this is sine. So sine, cosine, cosine, sine. So let me rewrite it. Sine of 90, I forgot to put the degrees there, minus a. So this is sine of 90 degrees, cosine of a. For sine, the sign stays the same. Cosine of 90 degrees, sine of a. Okay, so now the sine of 90 degrees is 1. Cosine a. Minus the cosine of 90 degrees. Cosine starts at 1 and ends at 0, so that's 0. Sine of a. And there you go. Cosine of a. We don't really need the parentheses. So this one was just a plug and chug kind of thing. Just work through it and get your answer. Okay. This last one, right? 9 cosine of 5x cosine 3x minus 9 sine of 5x sine of 3x. So cosine, cosine, sine, sine. Well, first let me factor the 9 out. And so you have cosine of 5x cosine of 3x minus sine of 5x sine of 3x. Cosine, cosine, sine, sine is a cosine one, if you go by your formula, where this has to be a and this has to be b. Now the sign we use, cosine switches signs, so that's a minus, so this is going to be a plus. And so it's going to be 5x and 3x, and then we can't forget the 9 that's on the outside. So your final answer is 9 cosine of 8x. So hopefully you got that one. That was just using the formula in reverse. All right. Okay. Apologize for the rough start on this video. Kind of in the swing of things now. So going to the next one, I gave you 3 problems. The first one is if sine of a is square root of 5 over 5 with a in quadrant 1, tangent b is 3/4 with b in quadrant 1. Fine, and here I'm asking for the cosecant, secant, and cotangent. So for this one, all I'm going to do is for cosecant, I'm going to find sine of a minus b, and then I'm going to flip it. for this one, I'm going to find cosine of a minus b, and then I'm going to flip it. And for this one, I'm going to find tangent of a minus b, and then I'm going to flip it. Okay. So we start with sine of a. I'm going to try to write small since the last time I did this, it took up a lot of room. And we're in quadrant 1, so my triangle is going to look like this, because this is Q1, or this is theta. Okay, now sine is opposite over hypotenuse. So this is going to be opposite. Hypotenuse is 5. And now this one's not an obvious one, so I'm going to label that as A. And we can do the Pythagorean theorem. A squared plus square root of 5 squared is equal to 5 squared. A squared plus 5 is equal to 25. A squared is equal to 20. So A is equal to the square root of 20. Now you can keep going because square root of 20 is square root of 4 times 5, which is 2 square root of 5. So a little more math work needed to be done for that. But we end up with our answer. We put that over here. And so this means that this A I can write as 2 square root of 5. And I can erase my A. Okay. So with that, I can now find the things I need. I know that sine of A is equal to what was given. And cosine of A is equal to 2 square root of 5 over 5. Now I can repeat the process with the cosine one they gave me. Oh, they gave me tangent. Tangent of B is 3/4. Well, that was nice. It's one of them. Okay, we're still in quadrant 1. But tangent is opposite over adjacent. So that means that this is going to be opposite over adjacent. And notice this is a 3, 4, 5 triangle. I guess I'll work it out. So we're looking for 3 squared plus 4 squared is equal to a squared. So 9 plus 16 equals a squared. 25 equals a squared. So 5 equals a. So that's how we got that. And with that, since we know tangent, I can figure out what sine of a is. Sine of a, sorry, not a, this is b. Sine of b is 3/5, and cosine of b is 4/5. So now I have everything I need. Again, I'm going to shrink things because this is a big problem. Don't be jealous of my skills. All right. So the first thing I'm going to do is I'm going to find sine, and I'm going to flip it. So sine of a minus b okay, and that is sine, cosine, cosine, sine. So sine of a, cosine b, the sign stays the same, cosine b, sine a. So we have sine a, square root of 5 over 5, cosine b, 4/5, minus cosine, oh, keep making mistakes. Sine, cosine, cosine, sine, but the a's and b's stay in the same order. And so cosine of a, sine of b. And so this gives us 4 square root of 5 over 25 minus 3 times 2 is 6. 6 square root of 5 over 25. And 4 minus 6 is negative 2. So we have negative 2 square root of 5 over 25. Okay, but remember this is sine, this isn't cosecant. So now that I have that, I've got to flip it. So my final answer here is cosecant of a minus b. The answer to that would be 25 over, I'm just going to put the negative up there, 2 square root of 5. So we flip it, but now we have to rationalize the denominator. So square root of 5 over square root of 5. And it's going to actually look really nice. So you end up with negative 25 square root of 5 over 5 times 5, 5 times 2 is 10. And then that simplifies again to negative 5, or you can divide by 5. So negative 5 square root of 5 over 2. Ugh. Oop, I was trying to highlight it or shrink it. I don't like this anymore. Okay, so for cosecant, our answer is that. Now we're going to move on to cosine of a minus b. So the formula for cosine is cosine, cosine, sine, sine, but the sign flips in the middle. So cosine A, cosine B, the sign flips to plus. Sine A, sine B. So cosine of A is 2 square root of 5 over 5. Cosine of B is 4/5. Plus sine of A is square root of 5 over 5. And sine of B is 3/5. So this gives us 8 square root of 5 over 25 plus 3 square root of 5 over 25. Okay, we do the work there. That's 8, 9, 10, 11. And then we're going to flip it. So now that we have cosine, we're going to flip it so we can get secant. My cat's throwing a fit because I'm not sleeping. So why are you awake? Okay, so for secant of a minus b, all we do is flip it. So it's 25 over 11 square root of 5. But then we want to rationalize it. So I'm going to do the rationalizing in my head. So it's 25 square root of 5. And then that turns into 5 times 11 is 55. And then 25 divided by 55, 5/11. So 5 square root of 5 over 11. Okay. I really hope that's right. I'm going to check after I'm done, and if not, I'll just send another email fixing it. Okay, so I got my cosecant. I got my secant. Now the next one is cotangent. Now for cotangent, I already have sine and cosine, so I'm just going to flip them. Notice they have the same denominator, so a lot of stuff is going to cancel. So for cotangent, that's just cosine over sine. So cosine is going to be 11 square root of 5 over 25 over sine. Sine is negative 2 square root of 5 over 25, and a lot of things cancel. The 25's cancel, the square root of 5's cancel, and you're left with negative 11 over 2. Yay! So now the last thing is, what is the quadrant of a minus b? So looking at this, sine, which is the same as cosecant, is negative. The only way that sine could be negative is if it's quadrant 1 or quadrant 2. Sorry. Ugh. Ugh. No, so this is sine. We ended up with a negative answer. The only way that sine can be negative if it's in quadrant 3 or quadrant 4. That doesn't make sense. I'm going to have to check this real quick. Secant being positive is... Oh, no, yeah. Quadrant... Secant being positive is quadrant 1 or quadrant 4. And so I forgot that we're subtracting the angles, we're not adding them. And so the one they have in common is quadrant 4. So a minus b is in Q4. All right. A lot of work. So anyway, that one was a toughie. Just a lot of algebra going on. But hopefully the logic was solid. You give what they gave you to figure out your triangles. Once you have the triangle, you can pretty much figure out any trig function. But since all the formulas have sines and cosines, all I need is sine and cosine. I do the triangle for the other one, find sine and cosine, and then just plug and chug into the formulas. So, this next one. If tangent of a plus b equals 3, and tangent of b equals 1/2, find tangent of a. This one is more straightforward, and it's just using the formula for tangent of a plus b. So remember, this is tangent of a plus tangent of b over 1 minus tangent of a, tangent of b. And as I look at my notes to make sure that I didn't screw that formula up, plus minus, yeah, okay. So notice they're giving us stuff. They're telling us that tangent of a plus b equals 3. And then they're telling me tangent of b is 1/2. Tangent of b, tangent of b. Okay, so I have tangent of a plus 1/2 over 1 minus tangent of a times 1/2. And all we got to do now is solve. Basically solve for tangent of a. So this is just a bunch of algebra. So the first thing we're going to do is we're going to multiply both sides by the denominator. Okay, so that cancels that out. So this cancels out. And if I distribute that, I'm left with 3 minus 3/2 tangent A is equal to tangent A plus 1/2. And now what I can do is I can just get my tangents together. So I have my tangent terms, and I want to get them on the same side. The other terms, I want to get to the same side. So what I'm going to do is I'm going to move that over here. It's minus, so this is going to be with subtraction. This one I'm going to move over here. It's subtraction, so I'm going to move it over with addition. And we get our answer. So 3 plus 1/2, 1, 2, 3, 4, 5, 6, 7/2 is equal to, and then if I add it over, it's 1 tangent. So I don't like the way I wrote that one. Anyway, so if you add that, 1 plus 3/2 is 5/2. And then the very last step is just to multiply both sides by the reciprocal. So there is 2/5. 2/5. So those kill each other. Boop, boop. And you get that tangent of A. The 2's cancel out, and you get 7/5. So this was more of an algebra problem than a trig problem, but you're solving for a tangent of A. Right, last one. Prove that tangent of x minus pi over 4 is equal to that formula. And so this is more of just using the tangent formula. So I know that tangent of x minus pi over 4, using the tangent formula, this is tangent of x minus tangent of pi over 4 over, and then 1 plus tangent of x tangent of pi over 4. Okay, tangent of pi over 4 is just 1. So notice the numerator is where we want it. And we have 1 plus, and then again, so this guy turns into a 1, this guy turns into a 1, and we're pretty much done. That's it. All you got to do is just swap the order. In addition, it doesn't matter how you arrange things. But now we got it looking like that, and my answer is done. All right. So again, hopefully the proofs were easy. For this one, I know it's a lot of work, but on the homework, there's I think 2 or 3 of them. So just be on the lookout. All right. Going to finish this off with 3 more proofs, and then I can go to sleep and sleep the sleep of 1,000 Gilberts. So prove that sine of pi over 6 plus x plus sine of pi over 6 minus x is the same thing as cosine of x. So let's use the formula. There's going to be, I'm going to color code them by with my highlighter. So for the first one, it's sine. So sine pi over 6 cosine x. For sine, the signs stay the same. So cosine pi over 6 sine x. So this is all of the first one. And there's a plus sign in the middle. Sorry, it's not there. We go. Plus sign, and again, it's another sign, except now the sign in the middle is going to be negative. So sine of pi over 6 cosine x minus cosine pi over 6 sine x. And so just from looking at it, before we even do any actual figuring out what these trig numbers are, notice that there's 2 terms that cancel out right away. The cosine pi over 6 sine x minus cosine pi over 6 sine x. These 2 terms cancel out. And so now all I'm left with is these 2 terms. But notice that they're exactly the same. There's 2 of them. So this is just 2 sine of pi over 6 cosine x. And so we figure out what sine of pi over 6 is. Turns out that that's 1/2. So this is 2 1/2 cosine x. 2 times 1/2 cancels out, and you're left with just cosine x. Yay! So again, if you're doing the proof in class, you would have to do all these steps. You have to kind of show me what you're doing. Anyway, next one. Prove that sine a plus b plus sine a minus b is 2 sine a cosine b. This is another plug and chug. So I'm going to do is very similar to what I just did. So sine cosine Sine stays the same. Cosine, sine. So that's my first one. And then plus, and then this is the same thing but with the minus. So sine, cosine, cosine, sine. My cat's meowing. She's in a tizzy. Okay, so the same thing as before. Cosine A, sine B, these cancel out. And exactly like happened last time, this is just a generic version of what we just did. Sine A, cosine B, there's two of them. And so that ends up just being 2 sine A, cosine B. All right, so again, 17 is just a generic version of 16. I know, kitty kitties. I know. So for this one, in the lecture, I went from the left side and I proved the right side. This time I'm going to do this side. I kind of worked on it between and I figured it out. So if I start with this side, it's very similar to the other one though. So the first thing to do is to turn the cosine a plus b into its form. So cosine, cosine, sine, sine. Except that the signs flip. So cosine, cosine, sine, sine. Here I have cosine squared a minus sine squared b. So what we want to do is multiply by the conjugate, just like we did in the last one. So the conjugate of this is this fun term, except it has a plus. Okay, and we work it out. Now I'm not going to do anything here because I noticed that this term that we did multiply, this is cosine of a minus b. And remember, secant is 1 over cosine of a minus b. So this in the denominator is where I want it. So I'm going to leave that alone. I want to keep that there because that part of the problem is done. So what I am going to do though is I'm going to distribute these guys. I'm going to multiply them. Anyway, so when you multiply, they're conjugates, so you're just left with cosine squared a, cosine squared b, and then minus, sine squared a, sine squared b. If you're confused on how I did that, look at the previous lecture, or the lecture above this one, and you'll see me work it out fully where I show why. Anyway, on the bottom I have cosine squared a minus sine squared b. And then I already know that's cosine of a minus b, so I'm just going to write cosine a minus b, because that's what that is. So in order for this to work, these two, the top and the bottom, have to cancel. But it doesn't look like they cancel. How can those cancel out? Now, in math, you can't just say they do, because that's what the final answer is. You have to actually show why. So in order for them to cancel, I need to keep, the top has to become, oh my god. The top has to become cosine squared minus sine squared. And so to do that, what I'm going to do is, here's cosine squared. So this cosine squared A, I'm going to keep. Sine squared B, I'm going to keep. And then the other two I'm going to change because I want to hopefully get rid of those. So still chugging. Cosine squared A, instead of cosine squared B, I'm going to say 1 minus sine squared B. Instead of sine squared A, I'm going to say 1 minus cosine squared A. And this is what causes them to cancel out. I'm trying to be formal and write it out every single time. It gets tedious, but it's what you're supposed to do. All right. Now I'm going to shrink it so I can save space. My computer said no. There we go. All right, so we just distribute. So that distributes, this distributes, but beware of that negative that also distributes. So I have cosine squared A minus cosine squared A sine squared B. And then if I distribute, that's minus sine squared B. And then that's a double negative, so plus cosine squared A is sine squared B. And then you notice we're going to get the cancelage that we want. So these cancel. And you can already see it's coming together. All right, and you can't cancel it's technically mathematically impolite to cancel both in the same step. So I know you're like, but I know the answer already. But you have to write this out. Cosine A minus sine B, sine squared B. Cosine squared A minus sine squared B. And then cosine A minus B. Now you can show them canceling out. So that equals 1 over cosine of A minus B. And then finally, 1 over cosine A minus B is secant. So this proof, there could be other ways to do it, but we got an answer, and we're free. I'm free. You know, oh my God. Gilbert wants to go to sleep, but it's trash day. And he spent the whole time cleaning the trash. On the plus side, my kitchen looks clean now. Anyway, so there you go. Again, when you're doing the homework, please upload the proofs to Canvas so I can actually grade them by hand. But yeah, have a good day. Time to go sleep.